Okay, welcome. Today we are going to discuss 5.5 in our it's in our book, in our packet. Introduction to slope. So slope is something that we'll talk about in 7th grade. Is actually talked a lot about in 8th grade, even more, and then in your algebra. Okay, so there's a few things that we need to talk about with slope and understand what they're asking and how to find slope. We'll do some exercises together, but at the end of the day, we want to make sure that we understand what is actually happening with slope. So does anybody want to read the definition of slope at the top? This is what you have in front of you, a packet. This might be a little harder to read online, but we'll kind of explain that to you. Anybody have definition of slope there, top left? What's it represent?
Slope represents the rate of change.
The representative change. So it could be the steepness, how fast or how slow an increase is. So ultimately what we're talking about is when you have a coordinate plane. Slope is actually telling us this. What the slope is of that line. The slope is of that line. The slope is of there. So where in slope is that important in real world? Where do you ever see slope? Anybody? Yes.
Say if you buy stocks, you can see like the price going up and down.
Okay, so that is a little bit like slope. That's telling you the price of the stock, whether it's going up or down. Okay, yep, because that is change. You're going to talk about that. Anybody else? How about slope as it is important slope of a road? Okay, so the slope of the road, the slope crowns off a road. Why? Why does the slope go this way instead of this way on a road? Because when it's
Because whenever it rains,
absolutely, when you want it to rain, you want it to run off this way, right? At your house, you have slope off from your foundation. You want the water to roll this way off your house and not that way, where it could potentially get into your basement or get into your house. Slope is a ditch. How steep it is. Okay, those are all important slopes. Slope of the sidewalk. Okay, they've changed some different restrictions. Slope of a wheelchair ramp. It has to be a specific slope. It can't be too steep. Okay, if it's too steep, then you have some danger when you're going down. So there has to be the correct steepness of the slope of a ramp, of a ditch, of the house. That's kind of your own. But of a road, who does that? Who measures that slope? Yeah.
Construction workers.
Construction workers, civil engineers, surveyors. If you've ever seen, if you ever watched when you're on the side of the road, you'll see somebody kind of with a tripod that has a little bit of a camera on it. They're surveying that, trying to figure out a little bit if the infrastructure, if the road's going to work, and how much to build it up. There's a lot of other things involved in there, but that is slope. Because if you have, and then also a golf course is also measured by how hard a golf course is. They'll have a slope rating, and that sometimes it depends. Measures the fairway, measures the green, how hilly it is. Okay, obviously the more hills it has, the more difficult the course will be. Okay, so you're looking at slope that way. But slope at the end of the day, we're talking measure the steepness and how fast or how slow it increases. So we're going to talk about that. Count on a slope between 2 points of using rise over run. So rise over run, which means what? When we're talking about a coordinate plane, what is y-axis called? That's the rise. X-axis. So if we have a line like this, we're looking at the slope, we're talking about this. How much did it rise over how much it ran? Okay, that's the rise over run. All right. So up is positive, down is negative, right is positive, left is negative. Correct? We understand the coordinate planes before. All right. So that's what it tells you there. All right. So now, a couple things that we want to talk about in slope. And again, you'll hit this next year and probably even in high school. Okay? When we talk about what actually is the slope of a line. Let me do something here. All right. Okay, so that mark right there is 2, 3, and that's 0, 0. Okay, so we're having a slope. The slope is going to tell us, here's the important part, here's slope. y2 minus y1 over x2 minus x1. What you determine as x2 and y2 is up to you. It's got to be consistent. That's really meaning the second coordinate. So it's probably easier to maybe do this one. Okay? So what do you have? What is y2? What's the y number on this one? 3. So this is going to be 3 minus what? 0 and
2,
minus,
0,
which equals what?
2, 3 over 2.
3 over 2. Now, you keep this. Slope always stays as an improper fraction. Got me? So what do you think the next dot's going to be up here? If we stay consistent with this, what is that dot right there, do you think? If this was 2, 3, and it was the same over time, rise over run.
4, 6.
What's that?
4, 6.
Because you went up,
2.
we went over 2, right? Rise, and then went up 6. So this is going to be 4, 6. Now, could you do that? Well, sure. Let's look at this. Okay, that would be 6 minus 3 over 4 minus 2 is 3 over 2. The slope stays consistent. Because what is this right here? It is a what? It's a straight line, right? It's going to have the same slope all the way through. Now they talk about a few there. What happens if you got a horizontal line? Okay? What is that? How much slope is in that? How much slope is there? How much slope is in a straight line?
None.
0. Okay, 0. So really what you're doing there is you're just going over x, right? So that's like, if you look at it, 3, let's say 2, 3, 3, 3, 4, 3, right? Why is it moving? Just going across, right? So the answer there is 0, which that means it's a 0 slope. What's slope on a vertical line? And in this case, it would be, the answer would be maybe 3 over 0, or 1 over 0, or whatever it may be. What's happening there is not possible. Okay? So that's what it says there. When you have a vertical line that's undefined, there's no slope possible. No slope. 0 slope. Undefined, 0 slope. Okay? All right. We will go over a few of these. Okay? I want you to flip to that second page on the back of the first page. Right. Should be 5.5 practice. What's the slope of that line on number 1? What do you have to do? You minus subtract the y's, right? y2 minus y1 over x2 minus x1. You got it for me? What's that? 5 minus 0 and... So the answer is 5 over... That's your slope. Now, how also, is this a positive or negative? Positive because it's going that way. Okay? If the slope would go downhill, that's when we get into negatives. Alright? How about the second one? What's the answer there? What's the y2 minus y1? x2 minus x1. What do you get? What's that? So 4 minus 2, right? Because that's the y's. And what are the x's?
6 minus 3.
And 6 minus 3. And you get 2 over...
3.
Okay, now let's say we wanted to do it the other way. And just said, okay, 2 minus 4 and 3 minus 6. Negative 2 over negative 3, which is the same as what? A positive, right? A negative equals a positive. Go ahead and do 3 for me. Anybody got that one? Who's got it? Caleb.
I did 3 minus 0.
So 3 minus 0,
And then I did 4 minus 0.
and you got the answer as?
3 over 4.
Good. 4. Anybody want to do 4? I'll see if you guys figured out the easy way to do 4 or not. There is an easier way. You might, what'd you do?
I did 2.5 plus 2.5.
2.5 minus a negative 2.5. And what?
1 minus a negative 1.
Okay.
And I got 5 over 2.
5 over 2. Okay. Be simplified into what? What would be the unit rate? What would be down to 1? 2.5 over 1. Could we have done that anyway? Because isn't that going through the origin? right? You can use any number on the line. Any number. They just identified 2 points for you. But you can use any line on there. Okay? Alright. I want you to do today 1 through 14. And you're going to find the slope. Okay? Find the slope on those. Then we will talk. Alright? Okay. Alright.